before determining the Fourier series coefficients, we must know that whether this sinusoid is periodic or not. So we must determine its period n. From lecture 4 and 5, we can recall that a sinusoid is periodic if its argument can be expressed in the form 2 pi k by n, where k had a specific meaning which you can see from the slides for lecture 4 and 5, and n is the period or the number of samples after which the signal repeats itself. So when we take k is equal to 1, we can determine the period n as 20. So after 20 samples, the signal will repeat its value. This in time domain. The time domain signal will repeat its value. Obviously, at the end of this discussion, we'll see that even in the frequency domain, the signal will repeat its value after n samples. So omega naught, or the fundamental frequency, is 2 pi by n, 2 pi k by n, which is 0.1 pi. Now when we open this sinusoid through using Euler's formula, it can be expressed as a difference of two complex exponentials because it is sine. So we remember that for a sinusoid, the Euler formula is sine theta is equal to e raised to power j theta minus e raised to power minus j theta divided by 2j. We open we separate these coefficients and compare with the synthesis equation. When we compare the coefficients with the synthesis equation, we'll see that we just have two coefficients and one of them exists for k is equal to 1 and the other exists for k is equal to minus 1. This period k, as I said earlier, could be taken over any number of samples. So you can take it from minus 10 to, in fact, minus 9 to plus 10 as well, 20, which makes 20 samples. So this k can be defined over any period. So for A1 coefficient, the value will be 1 by 2j, or if we take j in the numerator, it will be minus j by 2, which makes it magnitude 1 by 2 and phase minus j pi by 2, which is pi by 2, minus pi by 2. Similarly, for A minus 1, we have the coefficient minus 1 by 2j, and when we take this j in the numerator, it becomes j by 2. So j implies a phase shift of pi by 2 radians. This can be written as 1 by 2 into raised to power j pi by 2. So the magnitude for A minus 1 coefficient will also be 1 by 2, but the phase will be opposite and it will be pi by 2 radians. Let's plot this signal on the next slide.